for analysis. The parameters analyzed are: one, the physicochemical parameters, which included: one, pH, turbidity; three, the total dissolved solid, which is the TDS; then the fourth, the lead, Pb; and lastly, iron. For the microbiological properties, we determine the total coliform; then the second one, the Escherichia coli, which is called the E. coli. Then the laboratory analysis. The equipment we use for the laboratory analysis include the Hatch HQ40D, which is the pH meter; then the Hatch 2100Q, the turbidimeter; then lastly, we have the atomic absorption spectrophometer, which is called the AAS. Then we have the standards applied, the APHA, which is the Alpha Standard Method of 2017, the WHO Drinking Water Standards. Then we have the statistical analysis, which we use. We made use of ANOVA, the independent t-test, and the Pearson correlation analysis. Now, the results we obtained from the borehole water results, the borehole water analysis, the samples of the borehole water we collected, the analysis, we have the pH. The pH was found out to be the mean pH of the 5 samples. We have the 7.0. Then when we compared with the WHO limit, it's around 6.5 to 8.5, and we found out that it is safe. Then the turbidity rate, we used 2.3, we had 2.3 NTU, which is the nephelometric turbidity unit. Then when we compared it with the WHO standard, it is less than what? 5 NTU. Then we found it to be safe after comparison. Then the TDL, which is the total dissolved solids, will have 440 milligram per liter as the average. Then when compared with the WHO standard, we'll have less than 600 milligram per liter, and it is safe. Then lead. For the lead, we have 0.026 milligram per liter. Then when compared with the WHO standard, it is supposed to be less than 0.01 milligram per liter. Hence, it is unsafe. Then the iron, we found out that the mean iron was 0.15 milligram per liter, while when compared with the WHO standard, it is supposed to be less than 0.3 milligram per liter. Hence, it is still safe. Then the key observation is that the borehole water generally met the WHO standards. Then it is only the lead concentration that exceeded the permissible limit. Then the river water results. The river water results, what we obtained after analyzing the samples collected from the river sources, then the pH was found out to be 6.06. When compared with the WHO standard, it is 6.5 to 8.5. Then it is slightly acidic. Then the turbidity was found out to be 50.02 nephelometric turbidity unit, which is NTU. Then it is supposed to be less than 5 NTU. This is highly unsafe for consumption. Then the next one is the TDS, which is the total dissolved solid. We found it out to be 762 milligram per liter, and the WHO limit is supposed to be less than 600 milligram per liter. It is also very unsafe for consumption. Then the last but not the least is the lead. So when we analyze the lead, the mean value we obtained was 0.02 milligram per liter, and when it is compared with the WHO standard, it is less than 0.01 milligram per liter, which is still very unsafe. Then the key observation is that the river water quality was significantly poor. Then the heavy pollution was observed across river sites. Then the microbiological results, what we obtained from carrying out the microbiological analysis. Then the borehole water. For the borehole water, we found out that E. coli absent in all samples. There was no record of Escherichia coli. Then we have low total coliform contamination detected. Then river water, the parameter, that is the total coliform obtained in the river water, is 1,228 CFU, which is coliform unit per milligram milliliter. Then when compared with WHO, which is supposed to be 0, then the E. coli, we found it out to be 444 CFU per 100 milliliter, and it is compared with 0. So now the interpretation is that the river water showed severe fecal contamination, and it is highly unsafe for direct domestic consumption. The statistical analysis The ANOVA results, significant differences observed in one. We have the turbidity, TDS, lead, iron, total coliform, E. coli. The findings we obtained from the ANOVA results is that river water was significantly more contaminated than borehole water. Then secondly, the source type strongly influenced water quality. Then the public health implication from the observations, the major health risk is that what? There is a high risk of diarrhea disease, B, cholera, C, typhoid fever, D, gastrointestinal infection. Then lastly, we have lead poisoning. Then vulnerable groups, A, we have what? Children under the age of 5 are vulnerable. Then pregnant women, then elderly individuals. Then we have the community impact. Then how does this impact the community at large? One, we have increased healthcare burden. B, reduced productivity. And last but not the least, we have the poor quality of life. Discussion. Then borehole water will have relatively safer than river water. When we compared, according to the result we obtained, we found out that what the borehole water is relatively safer than the river water. We have elevated lead likely from the corroded pipes. There is what a high risk of what elevated leads in corroded pipes and geological contamination. Then for river water, we have high contamination linked to one, open defecation, two, flood runoff, three, domestic waste disposal, and lastly, we have the agricultural activities. That the key insight is that what access to water alone is not enough. Water quality is equally very important. Recommendation. Now, what we are going to recommend is that immediate action should be given to what? Boiling. Water should be boiled before drinking. Then we have routine chlorination. Then water should be adequately chlorinated before use so that what the germs and other microbacteria can be killed. Then we have routine chlorination. Then we have the household water filtration. Water should be adequately filtered. Then long-term intervention is that what? We have community water treatment system. There should be community water treatment system. Two, we have the regular water quality monitoring. Water should be what? Monitored in terms of quality. You have the replacement of old pipelines. Then pipelines should be what? Replaced as they are getting old. Then the last, we have the public health education. The public should be what? Oriented. Then we have the improved sanitation infrastructure. There should be improved sanitation infrastructure. Then conclusion. In conclusion, borehole water is relatively safer, but requires lead remediation. Then river water is unsafe for domestic use without treatment. Then water contamination poses significant public health risk. Then sustainable wash interventions are urgently communities. Then the final message is that what safe water access must include both availability and quality assurance. Then acknowledgement. We acknowledge the Confluence University of Science and Technology of Sarah, the Igwedo community leaders and residents, then the laboratory assistant and field volunteers, the African Research Group, the University of Lagos. We thank every one of you. Thank you for listening.
Okay, thank you very much, Silas.
Thank you,
sir. Thank you very much. I wouldn't know if there are one or two questions that we can ask from Silas. We wouldn't mind asking him a few questions.
Hello, sir.
Okay. Online?
Hello.
Yes, sir.
Good morning.
Very much,
Silas, for an interesting presentation and the work that I think is important for the community concerned. Based on the result you find is actually what we are expecting, especially in the as far as river water is concerned. We don't expect them to be safe for drinking. What are your plans and for working with the community in order to guide them to know how to handle or take care of their water before using them? I think that is very important, things that you can do. Either you yourself or you go to the community leaders and make an disclosure of what you have and find a way to take this information to the community. Then another thing is just before it was supposed to be the first one. Does the community drink the river water directly? If yes, then it is very important to make sure that you disclose the information to them. Thank you.
Thank you very much, Prof. Silence, quickly respond to that.
All right, sir. Thank you very much for the question. Firstly, the community people, they are not oriented on the aftermath of drinking water from the river, because most of them, they are farmers, and they have this notion that water from the river are safe for drinking. But after going through, getting the samples, we found out that it is very unsafe. That before they can drink such water, it should go through a concentrated amount of what treatment. So we made sure that myself and to the community, we discussed with the community head. Then in my presentation, I made mention of chlorine, then how to use alum and others in order to reduce the amount of what pollutants that are present in the water, and reduce the negative effect of what drinking water that are contaminated. So we made sure that we orient the farmers on what to do before actually drinking the water. And it usually happens during dry season, because then there will be no rainfall. So the borehole water is not as readily available as during the rainy season. So they revert back to the river water. Most of them do not carry out any form of treatment before drinking. So we made sure that we told them what to do before drinking the water. And we also told them what is obtainable if they continue to drink the water without treating the water. Thank you very much.
Okay, thank you very much, Silas. One question also here, and that will be it. Thank you.
Okay, sir.
All right. Thank you very much, Silas, for that wonderful presentation. I understand you are at the assessment level, but you are trying to solve a community problem. So I want to understand at what level are the community involved, right? And if at all they are not yet involved, are you thinking towards that direction? So I will need your quick feedback on that. Thank you.
Before you respond, sorry, there is another person that wants to ask a question, but we only allow the host. He also wants to ask a question. No, I think we would discuss that in-house, because we don't have though our food people are not here, but I want one of our pillar lead to give us a good way. So quickly.
Good morning, everyone. Good morning, my prof. My name is Emmanuel Oko. I represent a larger community. I would like to ask this question, and this question is bothering us in our community. Before we came into the community at Ilaje, and people that are living there before us, I think they use metal and all this waste product to feed the environment. So, and those particles now meant dissolve into the soil. For us to get a clean water is very difficult. In that aspect, what can we do?
Silas, that question is for you, but we will also be discussing it during our own, because this conference is a combination of scientists and community. And that's the reason why your work generates interest, because it's community-based. So quickly respond to those questions, and we'll move on from there.
Oh, okay, thank you very much. Please, I would like the first questioner to shed more light on the question. I didn't clearly grab what he said, sir.
What he said is that your work is at assessment level. You assessed the pollution level of the community, borehole and surface water, and every other type of water. That,
yes, sir.
Was the community involved in your work, probably during the course of doing it? If they weren't involved, do you intend to engage them? Or what is your plan in communicating your results to the community? That's the first question. The second question is a specific one of, if a community has there was a landfilling, and the landfilling is now contaminating their water system. They're asking what can they do?
Okay, thank you very much for the question. In response to the first question, the community, they are fully involved because before we took the sample, we went to the community head. We had a discussion with them, and they gave us their full support. Then, which was why I said in my presentation that after getting the analysis, we went back because it's not something that only us can completely eradicate or solve. So we had to, in our own very little effort, we give them the orientation that they need, so such that to be able to drop down the level of contamination of the water before they use it for their domestic activities. If we are hoping that the government should, in one way or the other, assist the community with what they need, even if they can bring in what they call water treatment plant, so that this river water can be abstracted and then undergo treatment before discharge to the reticulation unit. That's the answer I have for the first question. Then the second one, in a situation where we have landfill contamination, in a situation where we have landfill contamination, I believe back then we had a situation like that when we were working on abattoir contamination of water. So what we need to do is that to know we need to know the level of contamination, because we cannot start administering treatment without knowing the level of contamination. At first, water from such sources should what undergo experimental check. It should go into the lab for analysis. So after analysis, we'll now what ascertain the level of what contaminants that are present. Then we'll know how to what resolve such. Thank you, sir.
Okay, thank you very much, Silas. It's a pleasure to have you. With that, we have concluded our technical sessions. I'm not sure there's any technical session personnel that is available to us or sent their PowerPoints that we've not addressed. So thank you to all our participants for contributing and for sharing your knowledge with us. Before we go to the next thing, yesterday one of the pillar lead was initially with us, but because he has lectures, he had to leave. So I want him to give us a goodwill message. We have received goodwill messages from all the other pillar leads. So I want to invite Dr. Watunde Sawyer, the pillar lead of knowledge creation. All that we are doing is we are creating knowledge, to give us a short goodwill message. Thank you. Can we please give him a round of applause?
Good morning, everyone. All protocols duly observed. I was here yesterday, unfortunately, because of the delay in the opening ceremony. I could not be part of the opening ceremony, and that's why I could not give my goodwill message. So I'd like to recognize every eminent participant from the communities, the network coordinator, Professor Amuda, all members of the project, and participants, researchers, and policy makers that are part of us. It is my pleasure to welcome you all once again, and to say that on behalf of the Afretec knowledge creation pillar, I want to commend the University of Lagos for the role the university is playing in Afretec. The participation has been really effective and impactful, and is timely, especially at this point in the development of African nations to meet the sustainable growth development goals, of which water falls under SDG 6. And water remains one of Africa's most vital resources. Yet, millions of Africans still lack potable water. I've been to several parts of the world. Just open the tap and drink the water. Go to France, go to US, the water is clean enough for you to drink. But in Nigeria, you are playing with cholera and other infectious diseases. So this theme for the conference is timely and is very important in addressing access to water. In Afretec, advancing research on priorities. And we believe that universities must serve as the engine room for innovation, generating knowledge that improves the lives of people, strengthening economies, and supporting sustainable development. Water is central to public health. Water is important to food security, agriculture, climate resilience, environmental sustainability, and economic growth. As Fela will say, wet water, you no get enemy. There's no living thing that does not need water. So this conference offers that valuable platform to share ideas, present research, and build partnership. Present research that has been done and improve access to water. And I believe in the last 24 to 36 hours, we've been working on this to achieve SDG 6. So I encourage every one of us to continue to work in this space and this area to ensure that water is accessible to all. I'm confident that by the end of today, the networking, the sharing of ideas, sharing of innovations, insights, partnerships, and commitments that are made in this conference will lead to measurable results. Shaping stronger policies in our communities and in our nations. Building institutional capacities for our people and accelerating practical innovations that expand safe water access across Nigeria and across Africa. At this point, I would like to commend the organizers, Professor Adumbiade, Professor Amuda, Professor Fashanu, Professor Lawansin, for wonderful work, and the other members of the group, Dr. Yunusa, Dr. Ogundero, and the other person, I don't really know her name, I guess. Okay. So I'm really commending you for this dedication, this vision, and I urge all participants not to leave here the way you came, but to leave with something and clear vision of how to impact they are communities. And I want to thank the grantees, the efforts they've done in planting boreholes at 3 different communities. You're planning to do it. And I believe that will be a wonderful impact in these various communities. Because what I heard is not just to sink the borehole, but to bring in technology to make water portable and accessible to all. Thank you, and I wish you a successful and productive conference. God bless.
Thank you very much, Dr. Sawyer, for that goodwill message. We will go to the activity of today straight away. We've already started the activity of today, but one of the key activities of today is a group discussion. And I think 2 of the discussants are here, so we can start so that we will not keep us waiting. So I want to hand over to Dr. Yunusa to take up from here. Thank you.
All right. Good morning, and thank you so much, Mr. Chairman. Good morning, everyone. Welcome to day 2 of this conference with Team Strengthening Water Access and Quality in Selected African Cities. So we are moving to the round table panel discussion. The session is scheduled to be for an hour and a half, but we'll try our best to see how we can work with time. And in this particular session, you get to know about not just those doing the project, but about the project itself. And one good thing about this particular session is we have the community here to witness what we've done so far. So we are going to begin by first inviting the panelists, and we've designed it such that those that will be discussing with us are those that are experts. They have knowledge of what this project is all about. We've worked on this for close to 3 years, if not up to. So permit me to welcome to the stage the PI, the principal investigator of this particular project, the person of Professor H. Amoda. Please, let's give him a round of applause as he moves to the stage. Also, permit me to also bring to the stage the LOC chair, who is also a co-PI. For this particular project, the project is very, very interesting because we have 3 work packages. So, and the team is also well formed because projects nowadays should be multidisciplinary. So the PI, who of course I told you I call him my daddy, is from the Faculty of Engineering. Then the first co-PI is from Industrial Chemistry. You will see the formation of the team. So permit me to welcome on stage Professor Folusho Agunbuade, who is also a co-PI for this project. Now, the third person I would like to bring on stage is a senior colleague, someone I've learned a lot from. He's somebody that speaks calmly, but you need to be attentive so that you can go back with a lot of things whenever he speaks. So permit me to welcome the second co-PI on this project is a person of Professor Akifenwa Fashiano. We have the third co-PI should be joining us virtually. So she is Professor Taibat Lawansi. So I don't know if Prof is online, but she should join us virtually. All right. Do I have your permission to sit? Thank you very much. I will not bother with the opening remark. the need for knowledge creation, Dr. So has already done that. So I'll just move straight to the question. I will start with an icebreaker. So, and I would like to ask our panelists this question about water security. In one sentence, Prof, what does water security really mean? I would like the two of you to speak about it. Thank you.
Good morning, everyone. I think we've had wonderful sessions since yesterday. I want to crave your indulgence to digress a bit. I may leave any moment from now. Our pursuit is starting on Monday, and the meeting is starting. In fact, they've already started sending messages to me, and I'm the main person that will decide how the examination will go. So just permit me if I have to leave here. Now, the question is straightforward, literally, but when you want to look at it in terms of our environment, we can spend the next 1, 2, 3 hours discussing what is water security. But let's assume that we don't know anything about water security. When we mention security, generally, it is a sense or a feeling of what? Of being safe, free from what? Harm, either bodily or otherwise. Is that correct? So if we now take that into what we call water, the United Nations has come up with what they call 17 Sustainable Development Goals, and access to clean, safe water is one of the 17 goals. And we, as the VC said yesterday, represented by the Deputy Vice Chancellor, that water is what? Is life. It means in a simple, because we cannot be speaking grammar. So in a simple way, when you say water security, what we are saying is how can we sustain life by ensuring that people have access to what? Safe, clean, affordable, accessible what? Water. To do what? To ensure that they live a meaningful life. That is as simple as that. But when to go deeper, then we can start looking at the touch points, or what we call the value chains of water. The source, the treatment, the processing, and all other aspects of it. But so summarily, I can just say that water security is all about ensuring that our community, our people have access to safe, pure, clean water to sustain life. Thank you.
I would look at water security from a relatively different perspective. Prof has emphasized the issue of safety and other issues around it, but I want to look at it from the issue of rights. We all have rights to life. Nobody can come up and say, put gun to your head, I'm going to kill you. He doesn't have that right. No matter how much he's trying to exercise his rights, he doesn't have that right. I want to believe that water is also a right. So it doesn't matter whether I'm poor or rich, I should have access to water. The rich cannot take oxygen and say, okay, you can't breathe here. We are the only one that will breathe it. The same thing with water. Because I will only be alive if I have access to clean, safe water. So just like your security is your right, that is also your right. So from the perspective of water security, from the perspective of your right to water. Now, when it becomes dicey is I can give you right to water, but not the quality of water that you should have access to. I can say, okay, why don't you go and be taking water from the surface of the sea or whatever? I have denied you a right, but I've said I've given you access. So when we're looking at the total package of water security, we would say right to clean, safe, and affordable water. Thank you.
Thank you so much, Professor Lamoda and Professor Agbonbade. Actually, I've made my work very simple. I don't have to say any more thing. But I want us to look at water. The first thing is that in our universe, water is the most precious substance. Under our galaxy, the solar system that we operate, the same sun here, we don't know what happens in other galaxies. But in this galaxy, water is the most precious substance. To the extent that the people in space research, if they are looking for life in all the planets that they have been to, the first search is the search for water. So water is essentially, as Professor Amuda has said, water is life. It is the essence for which and to which we are here. And it is, take it or leave it, it is the most precious substance. You may have gold, but when you are dying, gold will not revive you. You may have all the assets in the world, and God has made it that way. So now Professor Agbonbade said, water is a right, just like it's not a right that is given by any of us in our association or gathering together or governance. It is a right that is given by God. And these rights and these privileges, as Professor Ilori said yesterday, has been an issue that has caused unity among nations. The umbrella that we are working is the United Nations umbrella, and it has also caused disputes across nations. Pamela showed us a picture yesterday of water, of a flow line between Pakistan and India, of a stream. If you go back to history, that stream had been a major problem, in the Far East between the two nations. And we almost had a similar thing here between Nigeria and the Niger Republic. So we have the Kanjiga Dam here. Then they just said, our brother, he said that you give us power or we construct our own dam. So people are wondering today that why would there be 24/7 power supply in Niger and we have erratic power in Nigeria? It is because the origin of River Niger and the largest part of its flow line is in the Niger Republic. So if we breach that contract, there are consequences. So the summary of it, water is life, water is our right, but the confidence of each and every one of us in a society to be sure that as we need it, that we have access to safe, clean, and affordable water supply. I think that assures us our security. Thank you very much.
Thank you very much, Prof. So you just had the taste of our panelists. So I'm very sure by the time you are leaving, your notes will be full. So now moving to, thank you so much, Prof, for that wonderful response to the icebreakers. Now to the first question. It is time for us to now understand the challenge, the problem we are trying to solve. For your information, this is not just a research in UNILAG or in Nigeria. It is actually a collaborative research between the University of Lagos and other university outside University of Lagos. That's University of Nairobi and University of Rwanda. So understanding the challenge, Prof, and I want to direct this question to our wonderful PI, because when you came up with this title, I was like, how were you able to come up with this title that showed the three work packages? And I could see I was with you when you were doing the proposal. I need you the amount of work that went into this. So I want to ask, Prof, we've gone to this stage across Lagos, Nairobi, and Kigali. What similarity and differences have we observed regarding urban water access? What similarity? Thank you.
You want me to go back to how we started? I need to say one thing. I am first and foremost a material scientist. In fact, I'm a welder. So the question is, how did a welder, a material scientist, was able to blacksmith all this together? And I always say one thing: if you have a PhD, a real PhD, there is no field that you cannot work in. The flow work is the same. The only thing that is different is the specificity of each space. In 2017, we had this program in UNILAG that was called Impact Week. That was the first time the concept of design thinking was introduced to the university. It was sponsored by Lufthansa, where you do ideate, synthesize, empathy, you test. So my team, which I led, worked on fire. And we went out to ask questions. What were their challenges? So we gave series of questions, but water came on top. And we decided to do something around that. But the project was still birth because Lufthansa is an airline, and I think their business model, or as it were, their sources in Nigeria, they were not making so much money again. So I think they couldn't sponsor the project, and that was how that thing went. So when Afretec came with one vision, which is Africa. Africans collaborating to do what? Solve Africa problem. That's everything, all the 2, 3, 4 pages of Afretec Charter. That is just one line summary. You and I should come together, sharing our expertise to develop solutions that will take Africa to the next level, as it were. So when they came, we looked around, looked at the challenges. And again, there was something that was very salient that they were not, it wasn't apparent. But you have to read the proposal line one by one to really get that. And what was it? Impact. Everything, they said they are ready to fund you. But that thing you do must what? Must make impact. So tell me, where can we make impact if it is not in the community that the university is cited? Another instance came when a team visitor from Finland. I just left as head innovation unit for the university. So they still invited me. And we were at the VC's office. So the man took over and look across the window, through the window of the VC. He was seeing a cocker on this side. And he said, Unilag is over 50, 60 years old, and you have not made impact in your community. That in Finland, that they've turned around their coastal community and your coastal environment. So when this call came, and the focus, very salient, they were looking at capacity building, but the main element in that call was community impact. So my mind just went straight to Iwaya. Then I reached out to Professor Lawrence, who is a person. I don't want to use the word because at times it's very denigrating. That are deprived or people that are vulnerable. Let me put it that way. That is our space. So I just reached out to her. I said, this thing, I'm an engineer. My own is to develop solution. You are in the community. What are the? She said, don't look at Wire alone. That also go to Ilaje. But in Ilaje, you have two communities. Agogo. And she said that our work is around working with people living in the slum. Iwaya is almost a slum. In fact, it's a triplex community. You will see people from very close to Unilag Akoka side there is a bit urban. Towards the other side is a bit mid-level. You leave that roundabout, going to where you have the police station, is more or less like a slum. So we now call it urban slum. It's not my land term. It's what? It's Professor Lawansin's term. And we found that from personal experiences, government has been doing intervention. They will come big and with fanfare. And in 2-3 months, they are bad. We said, I've been having access to water. The thing is that it's not, we cannot be sure of the quality. We are not sure of sustainability. And the requirement of that grant is that it must not only be in your university or your country alone, that you must relate with countries that share. So we put it across the network and we're able to get Senegal and University of Nairobi. Why did we want that way? Senegal is Francophone. It is also coastal. When you look at Senegal, it's also a coastal city, as it were. And they bear almost similar challenges to, whereas Nairobi is Eastern Africa. So, and luckily for us, they also have similar challenge in Nairobi. So along the line, Senegal pulled out. And we also got to know that Kigali is also facing water challenge. So we have to plug into Kigali. And one of the key aspects of the work is not the engineering. The key aspect of the work is training people to determine, establish the quality or do whatever they need to do to improve. The first thing is to establish the quality of what you want to use. And if it's not in the right quality, what do? You should be able to do something around it and make it what? Up to the level. That was how we came up with citizen scientist. This is the brain behind the citizen scientist. That is, people in the community should be brought in to be what? Of the solution. They are from the beginning. So whatever solution we are coming up with, we are developing with the community. When it is eventually developed or finalized, the community has been part of the development process. So maintenance, replication, that will be dropped along the line. So if it's faulty, they know what to do. So if we take it to another community in Lagos, maybe Lagos pick it up, they take it to another community, then those people that we have worked with will become the first set of expertise that we ensure that that was how we came up with community scientist-led approach to whatever solution we came up with, particularly around our environment, so that University of Lagos will be seen to have made impact in one, capacity building, two, opening up opportunity for business enterprise, and three, ensuring that people are able to ascertain the kind of the kind of water that they were consuming. And we also said, no, it's not like just like that. It's not just about citizen scientists alone. There's an engineering aspect. He mentioned in a presentation yesterday, using clay. We all know in those days we use such kind of material to do water filtration. But we now said we should inject science. We should inject engineering. What will determine the combination of we call it column here, right? That will determine the combination of materials that you use as your filter. You use charcoal, right? You use sand, then the other material.
Also use gravel.
That's what I wanted to read. So, and this will determine the flow rates. So we need to do what we call transport phenomena. For those of us from the community, what do we mean by transport? We all know that transportation is moving from one area to another. So in that filtration, we are saying, when you pour in your water, how does it move from where you pour it in to the point of discharge, which will now determine the amount of pollutants, organic dissolved solid or whatever, that will be removed. So at the end, when it is discharging, you can say this is the quality. So when you say transport phenomena, that is, what are those things that are happening there that is making my water to be improved? So that was how Professor Fashanu came in. And when we started that work, honestly, we met what we never expected. And that is why I will end my story with this. Or before that, there was another aspect of it. We call it resilience studies. And that is the stage of the work where we are in. What is resilience studies? We have come up with this solution. What was your situation before this solution was deployed? 6 months after it has been deployed, what is your situation in terms of behavior, in terms of health parameters, and some other? So I will end with this. When we started, we had our aspiration, our expectation. But when we went into the work, we saw different things entirely that has enabled us to become better. And that is why you will see in most research, in researches that have made impact, they are not They are things that came out of what we never expected. If you look at all innovations, all development, because science is not science is not sorcery. It's not babalawo, something like that. It's not. It deals with facts. It deals with data. It deals with logic. Similar thing is taking place in Nairobi. In Kigali, they are even it's almost similar to what we are doing, but not in that they came up with what they call selection matrix. So they are also using composites. Our own filtration, and they never did. So they are also doing something like that, selection matrix. That is, if you have this and this, you can get this, and this is what we. The same thing is happening in Nairobi. In Nairobi, the contaminant we are looking at more is is it fluoride? It's fluoride, yes. It's fluoride. Yes. So you can see across the three partners, where we are looking at biologically dissolved solids and some other parameters. In Nairobi, they are looking at other contaminants. You will now see that by the time everything is concluded, you will not have anything but have access to a more improved water that is very close, if not to the WHO parameter. And that is why we call it strengthening water access and security. It is one thing to make sure that people can access it, but is it sustainable? Is it avoidable, as Professor Fashan? So that is where the security comes in. And once we are able to do that, we expect that we should be able to replicate it in other cities that this similar demography, this similar characteristics as we have in this part of the world. Thank you.
Thank you very much, wonderful PI. In fact, your response, I asked a question, but you gave a response to two other questions. That's how you to ask. So, but before I move to the Professor Agumbiade, I would like to hear the perspective of Professor Wami. He's online, yes. So, I mentioned to you that we have collaborators from Nairobi and Rwanda. So we have participants also. They are also participating in this conference. So Professor Wali, I don't know if you have anything to say concerning this particular question.
Yeah, good morning, and thank you very much for inviting me to say something about this. Uh, uh, I think when we are about our own project here, the issue is actually to establish water security in the community that we are dealing with. And based on the, hello? Are you hearing me?
Yes, we can
hello?
hear you. Yes.
Yeah.
Yes.
So, when we say water security, already the presenters has already defined what it means by water security. So to put it in a nutshell, it's a situation where we have water available of sufficient quality, and it is accessible by the user depending on what you are using it for. Either you are doing it for domestic activity, for agriculture, for tourism, or whatever. And also reliability to ensure that all the time when you need that water, that it is available, you can get it, you can use it. And then we also talk about the risk management related to it, that there is no risk related to water, to manage the risk like flood and like drought, and also to ensure good governance in managing water resources. So that is what we are targeting to ensure that our community gets access to water security. And in our project here, as you already hear from our I'm not going to repeat all what he has said, but our target is to ensure that the community are water secured, and then they participated in the activity, they know it, they understand, and also they can manage it themselves. So that is what we are doing. Thank you very much.
Thank you very much, Professor Wali, for that wonderful response. Before I proceed, I would like to also bring to the stage other members of this team. You know, in Unilab, inclusivity is very, very key in whatever we do. And our professors train us such that even when they are not there, they have people that can take over. So that is why if you check the banner, you will notice you have professors and even the upcoming professors in quotes. So I just want to welcome a colleague to the stage. He's going to be shocked, I don't know. Dr. Michael, please come to the stage. He was the PhD student on the project, but he's now a PhD holder on that same project. So also for the purpose of inclusivity, Dr. Cheta Odinaka will also be joining us. So I don't know, can you get a chair? Okay. Okay. Dr. Cheta, please come to the stage. All right. Thank you very much. So let's proceed. Our ONC chairman, sir. You've answered this question during one of our community engagement session, but I want you to also, for the benefit of our participants, you gave a wonderful response. That was why I intentionally included it in the discussion for today. Why do many African cities continue to experience water shortage despite abundant natural water resources? Is it primarily due to infrastructure, governance, finance, technology, or public behavior?
Thank you very much. Let me start with the story of what happened in Cape Town. Cape Town is a city, or is a city that is bordered by two Atlantic oceans. You have two oceans, not Atlantic Ocean at one side, Indian Ocean at the other side, and the two of them meet in Cape Town. So a city that ocean everywhere, but there is water shortage. There's no water to use in Cape Town. The number one reason why water is a problem is the chemistry of water itself. Water is a universal solvent. When it comes across anything, it dissolves it. And when something has two components, it's no more pure. When you say something is pure, it has only one component. So once water has any other thing in it, microorganism, metal, any other thing in it, it's no more pure. Yes, sometimes it may be potable because there are some things that may be in water that is useful. So it may be potable, that is, we can drink it, but it's not pure. So the real problem is the fact that the nature of water, and that's the reason why we will continue to look for solution to it. The nature of water is that it comes in contact with anything, it dissolves it. The rate at which it dissolves it may be different. The rate at which it dissolves some things may be very fast. The rate at which it dissolves other things may be. If you have a building and water is on it, after some time you will see it coming out from that building because that's its nature. So yes, there can be problem of governance, there can be problem of treatment, and all other problem. But the key issue is the nature of water itself. Now, having known that that is the nature of water itself, we are now going to start to look at, okay, how do we remove anything that is impure from water in a way that is cheap, in a way that is affordable, in a way that even a lay person can do it. And that is the reason why this project is quite fantastic. We are looking forward to a point at which a lay person can be able to pick up what we have done and be able to say, okay, if I add this to this, I can come up with a solution for water treatment that I can treat in my home. And I've used example. We all use during those days. Water is put in pots, in clay pots. Why is it put in clay pots? Because clay is natural. Clay can sieve. Clay can remove all the impurities. Other than we use this one, and this one that we are using, water is dissolving it. There is a key area of research now that is called microplastic. That's the reason why Professor Wally may confirm to us. I've been to Rwanda about 2 or 3 times. They don't use plastic bottles. They use glass. Because you know that glass is also made from clay. And the Bible even told us that we are from clay. So in any case, clay-based materials may be better. Sand-based materials may be better for us to undo water issues than for us to use steel, plastics, and most of these other things. So it is actually the issue of the nature of water itself. And every other thing is secondary to it. One can be having governance issues about treating of water. Some government is actually preferring not to provide water in taps, and some sponsor boreholes and the likes of that. Whichever way we want to look at it, all of them comes back to the chemistry of water itself. What is making it to be what it is? Thank you.
Thank you very much. You always see Chair, Professor Agubiadi, for that response. So to the next question, I'm coming to you, my fellow colleagues. Let me handle our guys first. Prof, in this project, we are not just doing research, impacting community, but we're also making our work known to the world at large. And how have we been able to do this? By publishing the results from this research. And we've been able to publish work from this research in reputable journals, Sage, Springer Nature, Elsevier, Taylor and Francis. These are quality top journals that research outputs that people are always, people would like to put their journal, their works in. This research output that of course, this research has actually produced excellent publications. We've been able to validate that. But what the community needs is practical solution. How do we bridge this gap? Thank you, sir.
Thank you so much, the moderator. I want to just have a reflection, one, on what Professor Muda said before he left, and also on some of the things that Professor Agubiadi just told us. Now, the project, when it started, demands that it must be multidisciplinary, and it must also be, when I say international now, it must be cross-continental. So we had the University of Nairobi and also have Kigali. Now that brings me to the issue of knowledge and indigenous African technology. I happen to be somebody that was following my father. By the way, my father was an agric extension officer. So a lot of times he was working with what they now call British American Tobacco, was Nigerian Tobacco Company then. So they were actually growing tobaccos, and he was like mainly building tobacco barns, what we call ovens now, across the northern part of Oyo State. So each time we're on holiday, we have to move from town to where he was working. And there was severe water challenge. During the rainy season, no issue. But I remember 1 or 2 towns in Oyo State, we can still be verified. The water they have there is called, when I went to school, read chemistry, I now know that it is called hard water. So this water is not as smooth as the one that you have. It is heavily mineralized, as Professor Gumede just said, because when it touches everything, it dissolves everything. So it's hard water, and before it gets hard, even before we can get to the point of drinking it, it is turbid. It is turbid, muddy water. But I realized then, even as a child, I'm sorry I'm taking a longer part to this question, that even as a child, the community, the people in the community, they put this water in calabashes. And there is a particular leaf. I can't, if I see the leaf again, maybe I will recall. There is a particular leaf that they will cut and put on the water. So they don't have access to what we call alum. I don't know what we call alum now. so they don't have, so in our own seclusive part of the community, maybe daddy will buy alum from town, then we use it. But these other people don't have alum. They don't have alum. And I also interacted with some of them, because as children, you have to. So I realized that the water they drink in their house is better than the one that we drink, because we are treating it with alum. But they are treating it with a special leaf. So, and there has been this fundamental knowledge gap from traditional technology and localized solutions, even across the Yoruba land itself. Now, to talk of across Nigeria, I also happen to live in the north. Different solutions, different communities. And one of the problems that we have faced as a people, as African, is because we don't actually document, and it's also difficult for us to transmit knowledge. So it is essential that whosoever is funding, so like Lagos, if we people that are living in Lagos, I can tell us here that we don't know what God has done for us in terms of access to water, either pure or otherwise. There are some communities in Nigeria, even in this Nigeria, that are starved. They are faced, there's a heavy water crunch. It is when you have the water that you can think of purifying it. But by times when you don't have the water. So you have to, sometimes they have to sink holes several kilometers down into the ground before they can access water. So the real essence research is the ability to communicate the knowledge that is gathered within the research. And even then, you don't just transmit this knowledge anywhere. There are places where you are going to put information that it is going to be like you have locked it, you have taken it away from the world. But so there are places where the researchers go to look for knowledge, to seek knowledge, to place their, so that they don't have to invent the wheel all over. So that is why, one. So when we started this work, we also set up a framework for sharing knowledge within the communities that we are working with. So we created what is called a database, and we put a framework of digital innovation, which is called Internet of Things on it. So whatever we are doing in Lagos, real time, and the measurements that they are taking from water in Lagos and the response of our water in Lagos, whatever technology that we are using to improve on it, is being transmitted real time to people that are in Kigali and the people that are in Nairobi. So that the losses that our parents have suffered as a result of knowledge, bridge and knowledge gap is not transmitted into the future. So those are the things that we have been assisted to deliver on this work. I said yesterday, and it's also sure here, that in Nairobi, that's my experience, that it is cheaper for me to get a glass of juice than to get a glass of water. And I can tell you, there's no amount of juice that you will take that can quench your thirst. Thank you so much.
Thank you so much, Paul. No amount of juice you can take that can quench your thirst. I love that ending. Now, Dr. Gudo Obawika, your question is going to stem from the response given by Professor Fashanu. And of course, it is something you actually did. You got a PhD on this grant. That's fantastic. And we work closely. So I know you are very hardworking, and I know when it comes to Internet of Things, app development, these are things you have expertise. So I want to ask, what emerging technologies have the greatest potential to improve water quality monitoring in African cities? So is it AI, IoT, remote sensing? Is it digital twin, low-cost sensor, indigenous technology? Because just like Prof mentioned, we get real-time data from our communities in Iwaya Ilaje. So can you take us to how you were able to achieve this and then use that to kind of like answer this question? Thank you.
All right. Thank you, sir. Even though you did not prepare me for this, no problem. Yeah. What emerging technologies? So I'm going to go through, my PhD route, what I did with the assistance of my professors here, in order to change or revolutionize water quality monitoring. Yeah, then when we started the work, we planned to install sensors and also ensure that we communicate water quality data. So what we are saying is, in the water, we have different parameters, and we even call some physical parameters, some chemical, and some biological. So what we did then was to install sensors, although we could not install them permanently because of security issues. So then we went to Adefe Memorial School in Iwaya, and we trained some of the students, on how to capture water quality data. And they were helping us to do some of those things. And with the IoT implementation, we were getting the data they were capturing from our place. And with those data, that is the real-time value of pH, the real-time value of dissolved solids, and all of those things. So we were able to come up with the filtration materials that we used for our experimental study. Those were clay, sand, and activated carbon. So how did that, help water quality monitoring? And what are the emerging technologies? AI also. So at some point, because the cost of measuring some of these water quality parameters is, high, the cost of acquiring some of these sensors. So we deployed some AI tools that we called soft sensors that were able to predict the parameters that we could not measure. So from historical data, or not just predict the ones we could not measure, probably ones that are missing, let's say, for example, on a particular day, our sensor is actually faulty because we used to calibrate those sensors before we take them to field, and we may lose calibration at any point in time. So let's say the pH sensor loses calibration and the sensor is not able to report the accurate value of pH at that point. What do we do? And we need that information. So we developed soft sensors, which are machine learning algorithms, through historical data, so that we're able to predict what will be the pH value of dissolved oxygen or temperature of water at that point, because we need those things to be able to tell that, you are going to need clay for filtering your water at this, point in time. You are going to need activated charcoal, to filter your water. So all of those information are very important. So in that regard, we're able to deploy AI tools to give us estimated values of water quality data. And we are still doing more research. So it did not even stop at my PhD level. And I'm still coming back to my professors because currently we are working on using biochars, that's palm kernel shells that we have in our community. So we eat it, it undergoes, different, it undergoes a process. And why are we introducing this? Is because the earlier work we did, we considered physical properties and chemical properties. But today, I think Professor Amda mentioned that in Nairobi, they are looking at fluoride. So here, in fact, the test results just came in this morning of the metal test that we did, copper, zinc, and all of those things. So, and that is why we're introducing palm kernel shell. And even with IoT, technology, we can tell that, during this season, you don't need to use palm kernel shell, So those are the things technology will help us to achieve so that you can get specific solutions, that are tailored to the current water situation. Thank you.
Thank you, Dr. Michael Ogundero, for that wonderful response. So I want to ask Dr. Chita. Dr. Chita did water-related research for a PhD as well, and she came on to join the team, and she's been supportive in every aspect. We were together doing the citizen science engagement in Iwaya Ilaje. So I want to ask, you think has surprised you the most during the implementation of this project? What? Just anything. Because coming from your PhD, which is water related, then you just enter the water project. So connecting the PhD with the project you're currently implementing, what do you think has surprised you the most? Thank you.
Okay, thank you very much. Good morning, everyone. Good morning, professors. Good morning, my colleagues. Good morning, the community also. Well, I might not really say it's a surprise. Okay, because I think I knew, like you said, I joined the team. They graciously accepted me. So, and I had learned, or I found out what the grant was about. The scope of work that was going to be undertaken during the project and all that. So I wouldn't say I was really surprised, but I would say I was very impressed because I think the research I was more familiar with didn't really have a lot of community engagement aspect. And I think that was, in fact, when I found out that this project covered it, that was one of the things I really wanted to gain experience in, because personally to me, I feel that research just staying on the shelf or being published, in nice journals is not that useful. I might be very wrong, right? But I think that the research should be beneficial to the people in that immediate society. Sometimes the people in that immediate society don't actually read our international journals, right? So you have the solution, it's out there for the world, but the people that could be most impacted don't even know it is there. So it doesn't really, really help them, So I was really very interested in how the project was going to work hand in hand with the community, because I also found out that the community were also like taking samples, and also they were very involved in the project. And so that's one of the things I really love about the project, to be honest. Thank you.
Thank you. Thank you so much, Dr. Ichita, for that response. Mr. Chairman, sir, the communities are here, and we've been working with them from the inception of this project. How important is citizen science and community participation in improving water management? Speaking from the angle of the project. Thank you, sir.
Thank you very much. I'm tempted to speak Yoruba because they're asking me about community. I know our community people understand English, but when we speak our language, sometimes it comes home. Professor Pashanu mentioned a community-based solution in the northern part of Oyo State. And those knowledge are still very, very, very significant. But we just come up with research. I want to load it over the community and say, okay, oh, we have done so, go and start using this. The buy-in will not be there. If I may, it is likely, though moringa is not common in that time, there have been studies that have shown that if you take a leaf or a stem of moringa, it has a good coagulating property. It can coagulate pollutants, match them together, and remove them. I know that when we were young, if something is smelling, or if water is smelling, you can put charcoal. That's active carbon. Odoriferous material, they're throwing it in. The truth of the matter is that there is knowledge in the there is knowledge with the community. And if we are looking for a solution for a community and we don't carry the community along, we don't involve citizen scientists, there won't be a buy-in. If you want them to implement it, you just say, all this one that you're saying, you are just speaking to Renchio. You don't understand all this one that you're saying. But if they were part of the process, and you now say, okay, take charcoal, put it inside your water, it will remove pollutants. Take clay, use it with your water, or this is a tea bag of clay and charcoal. Just soak it in your water before you drink it. It will remove any contaminants. They will buy in because they were part of the process. That's one. Two, the knowledge, like Dr. Echeta said, the knowledge will be preserved in the community. It won't just be, yes, because we have to publish it in very good journal because we have to, it has to be internationally validated. International community will have to validate. That's the reason why we published it in very good journals. But communicating it to the community, if opportunity permits us, sitting down with the community to even test or to even practicalize it. Tẹ́ bá mú eléyìí, tẹ́ dàpọ̀ mọ́ eléyìí, tẹ́ gbé sínú, tẹ́ gbé lórí náà báyìí, yóò fún yín ní nǹkan tí ó lè yọ ìdọ̀tí kúrò ní omi yín. Once we are able to practically explain it to them, it becomes a knowledge they will also pass over to other generations, to other people. It won't just be lost in the book of the international community. It will also be a knowledge that will be present with us. I will conclude by saying that we will have an opportunity to get feedback from the community too. But I will conclude by saying that we have learned a lot when we're engaging with the community. There is a part of the work that Victor did. There was a literature search that is also published. There was a literature, survey, questionnaire-based survey, trying to look at, okay, if I come up with a technology, one of my students presented yesterday from University of Ibadan, and he was using membrane, some of these things, and I deliberately asked him a question like, what is the average cost of the membrane? And he said something about probably 200,000. So if you now come up to a community and say, I want a membrane, you need 200,000. I want a university to do. if there is something that is affordable, that is a knowledge that is created with the community, and they themselves can use that knowledge, then it becomes something they can buy. And it becomes something they can, and when I say buy, I'm not saying as in using money to buy, but buy into it. And they can also say that, okay, wọ́n kọ́ wa nígbà tá a lọ sí university, ọgbà táwọn ará university wa, wọ́n kọ́ wa pé tá a bá ṣe báyìí, tá a bá ṣe báyìí, tá a bá ṣe báyìí, we will have solution to a problem. I got this idea from a WHO World Bank project that was carried out in another city, and they were actually just teaching about chlorination and some other concepts that are just basic. But we must always engage the community in coming up with innovative ideas that is cheap and they can pick up. Thank you.
Thank you so much, Mr. Chairman. Before we allow, we open the room for our audience and participants to also ask their question, I would like to do we cannot wrap up this session without mentioning the university. So I want to ask, Prof, what role should the university play beyond conducting research? Should it be capacity building, policy advice, innovation, entrepreneurship, or should they support community engagement? Speaking from the angle of this project. Thank you, Prof.
Thank you, and thank you again, the moderator. When we talk about capacity building, entrepreneurship, getting the outcomes of research to the markets and etc. I think our University of Lagos is doing extremely well. Although they said that it is a child who has not been to somebody else's father's firm that says his father's firm is the biggest. Because I read something about the research outcomes in the Oxford University and how some patents are actually transforming. And I pray that, and I know that if we keep on the lane that we are and we don't look back, someday also we will also get there. I also want to go back to the beginning of this project. And when Professor Muda said that if visitor came, looked outside the window and said that maybe University of Lagos has not been impacting directly so much on the community. I also want to advise and encourage all our colleagues that are doing one form of research or the other to please extend some of the outcomes, even some of the knowledge search to the immediate community. And I also, because a lot of things are happening, if we live in this community, the community should feel an impact. You know, there is this Yoruba adage. I'm sorry, it's also you that says that I'm also very sorry to use this idea. When we said one rich man in the middle of people that are not as privileged, they are all unprivileged. And when we also talk about the security situation of the country today, it stems from that philosophy too, that we don't take care of your neighbor. The holy prophets and the scriptures, the first commitment that they gave to us is that we should love our neighbors as ourselves. It's only when we love our neighbors as ourselves that we can actually talk about the security that we are thinking about. So I think that's my little submission on that. Thank you.
Thank you very much, Prof. Now it is time to hear from our audience. But before we do that, can we please give our panelists another round of applause? It is not easy, right? Maybe go, Prof. So we will now welcome questions from the audience. If you have any question, please just raise up your hands and then we can allow you. Okay. So 1, 2, 3, 4, then 5. Okay, please permit me to go anti-clockwise. Thank you.
Knowing my academians, we're very privileged to be part of this great forum. My name is Honorable Taiwo from representative from Agoigun CDA. During the conversation concerning the water quality that we've been discussing, I brought down some points that I would love to put the question across. Because before going forward, I want to appreciate our professors, Professor Agumbiada and Professor Fashanu, for enlightening us more concerning what we need to understand about water quality. Well, my first question goes like, what was the percentage of the borehole that was tested when the former colleague was giving his summit concerning the research that's between the borehole water and the river waters, that mostly the borehole water were more preferable in consumption than the river waters? But what percentage of the boreholes were as in taking for them to have that aspect that, okay, borehole waters are more conducive than the river water? That's the first question. Should I go through all the questions? Okay, the second one is that I want to ask that when the research were being given, the terms and terminology that was given to be understood by a layman is very difficult. Because even some of us that were privileged to have little academic knowledge, when they were talking about papaya and stuff, we were really finding it a bit hard to understand and digest. But when they now told us that papaya means pawpaw seed, then also plantain peel, that easily as in sinks into our knowledge. So how can we now break down these informations for the layman that we're not even privileged to have that, to have the aspect of having education? That, okay, if you have this, if you have that, as you have said, that when we're able to communicate with the community, it gives the memory chain a stronger line to pass it on. So please, what can we do concerning this research to break it down to the layman's understanding? Because mostly others are projects that is being done is to have an impact in the community. That is it. And one last one I want to ask also is that, what is the security aspect? As they have said earlier, that it's not a privilege for us to have water. It is by right for us to have water, not just any water, but a quality water for us. And now we are having so much aspects of paying. Is it that they are denying us our privilege as citizens to have a quality water? For us going to that extent, paying for what we deserve or what is our own rights. So please, we want those little clarifications. Thank you very much.
Thank you very much, Prof. Prof, which do you prefer? I gather the questions or you respond? Okay. 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 So acronyms. Yes, you want us to? Okay.
Okay, thank you very much. I will start with the last one. We will still have to pay because we're actually paying for the treatment. And it's the only one that we are not paying for is oxygen. But God forbid that we should be sick. You won't say because that one is a treated form of oxygen that you have to be given. So in any case, we have to pay for the process of treatment. But if we can get to a point that we can treat ourselves, it's still going to cost us something. But it's a right. You can't deny somebody water. You can't. It's a right. So the only thing is, I can't say because I am rich, I'm going to show that I'm rich by polluting your own water or not allowing you have access to water. And some that even you notice that God has so designed, it's only that now we have a lot of people digging borehole. If you dig a borehole as a rich man and you're not giving people, that borehole will start smelling. What does that show you? that you cannot live on it alone. It has to continue to flow. And that flow, by giving it, is the one that replenishes it, that gives it. So it's on the issue of bringing it down, you see, it's just an habit with all scientists. And we have to learn as much as possible. They are teaching us scientific communication, how we communicate to the scientific community and how we communicate to the general community. For instance, now, if I didn't say papaya seed, a professor of botany will say, which kind of literate professor is this? How is he calling it purple? But the scientists will even say he didn't utilize the papaya seed because it's a botanical name. What I'm trying to say is báwa ṣe ń communicate nìyẹn, ṣùgbọ́n a gbọ́dọ̀ wá bá ṣe máa ṣe, especially tá a bá wà ní community tó jẹ́ pé àti àwọn tó jẹ́ scientist ló wà ń bẹ̀ àti àwọn tí ò jẹ́ scientist. A wá wò pókè ní tí mo kọ síbẹ̀ tí mo pè ní papaya seed o, èso pọ̀pọ̀ ni tẹ́ bá ti ń ṣe èso pọ̀pọ̀ yẹn má dànù. Ìbẹ́pẹ ní tẹ́ bá ti bẹ ìbẹ́pẹ yìí, èso tó wà nù ẹ má dànù, ẹ lè fi ṣe kóró rẹ̀, ẹ má dànù, ẹ lè fi tọ́jú omi yín. Tẹ́ bá mú ọ̀gẹ̀dẹ̀, tẹ́ bó èpo rẹ̀, èpo yẹn ẹ nídìí àti dànù, ẹ lè fi tọ́jú omi yín. Ìtì ìwádìí wa sọ jáde nìyẹn. Ọlọ́run ràn wá lọ́wọ́, àwa náà máa kẹ́kọ̀ọ́ láti máa lo àwọn ọ̀rọ̀ tí ò tóbi tí ò tóbi, but nítorí pé wọ́n ṣe bá a ṣe kẹ́kọ̀ọ́ láti ìgbà tá a ti bẹ̀rẹ̀, ó ti wá di nǹkan tó mọ́ wa lẹ́nu. Tó yẹ pé ìgbà míì wà, and ọkùnrin kan wà tó wà ní Facebook tó máa ń ṣe sáyẹ́ǹsì Yorùbá. Mo máa ń gbọ́ torí pé ọ̀pọ̀lọpọ̀ àwọn ọ̀rọ̀ láàní fún àwọn nǹkan tí à ń lò sáyẹ́ǹsì tá à ní Yorùbá rẹ̀, but òun ti ń bá wa ní Yorùbá rẹ̀. Bóyá àwọn tó wà ní art, bóyá wọ́n lè máa ràn wá lọ́wọ́ láti come up with words for some of these things. Though àwọn tó wà tó wà ní orúkọ rẹ̀, but words for some of these things, so that when we are communicating, we will communicate with those words. It becomes very easy. It becomes very easy. And truly, in my departments, when a student comes to present and is presenting on things that are natural, that are in our environment, we always insist that you should put the Yoruba name. That if you're saying, okay, I work on moringa, kini one call moringa in Yoruba, so that if you are communicating it, you can be able to say, tó bá mú èso igi yìí o lè ṣe nǹkan báyìí. Ó dà bí mo ti gbàgbé first. Okay. That was the study of a student, but I can speak to it that many research work that we've done over the years have established that bottled water is safer. I'm not saying it's completely safe, but it's safer than surface water. Professor Wali in Rwanda asked a question from that student. And that student, well, her question was that, do they drink surface water directly? There are many places that they don't drink surface water directly again. It's only in some rural areas. Will somebody in Lagos look me? What's in some of them can still go and collect surface water. So that's the reason why he is asking that, okay, in that community, do they collect surface water directly? Most people, because nature has done it in such a way that the water that we are taking from the ground has gone through clay, sand, and all those things before it gets to the ground. So it becomes a bit better I said a bit better because I said water, when it comes in contact with every other thing, it comes in contact with so many other things that can also make it bad, can make it hard. In some places, Kangarambi, latrine, it's okay, and we're assuming that that's process. So it's not perfectly okay, but it's somehow safer than surface water. So research work has established that to a large extent. Also, we harvest rainwater. We've done studies on harvesting rainwater, that we will just harvest it. Sometimes the roof can be a problem if you are harvesting it. We did a work in Port Harcourt. We harvest rainwater from without contact with the roof, and the pH was 2. Acidic, but if we can't conclude to say it's not safe, because you know that the pH of Coke, pH of Lacacera is also 2, which is also very acidic. But because our stomach, God has designed it is acid. There's acid in our stomach. So we can still say it's not pure, it's not good to drink it, but we can't conclude to say because the pH is low, but harvested rainwater is also good. And many people have lived on harvested rainwater. And that's the reason why when Parimela was presenting yesterday, she was presenting on harvested rainwater, that they now charge it into the reservoir that is under the ground, that is aquifer, so that when there is no rain or there is no water, they will not start to tap it and be using it. So knowledge is going all around on looking for solution to water. Thank you.
Thank you very much, Prof. So the next question.
Sorry. I thank the organizer of this program. Yeah, okay, so A.P. Ogunyan is my name. I'm from Ilaje community. Yeah. Now, this type of program, we learn a lesson from it. Like me, I pick 1 or 2 things. But what I just want to shift because of time, I'm into water, borehole water business, which Malam and the public came to fetch. Now, the affectionate was of recent, we detect that we are getting salt content from the water. Now, I move around, maybe I can get somebody who can assist us just to purify the water. But some people told me that there is no chemical, something that they can use to remove the salt content, that if they told me that there is, I should not okay with them. They just want to collect my money. I say, okay, this forum, I think is water. And what we are discussing about is water, clean water. Now, I hope that maybe I can get solution from here, because it affects most of our people in the larger community. The type of water we get, the salt. So I don't know. That is the question I want to ask. Thank you.
Okay, thank you very much, sir. Prof.
Thank you so much, sir. And thank you for being part of us. What is happening to that borehole? I think before a time, the water was good, sir. It was good. Then all of a sudden, it got salty. Yeah, and I can tell you that, one, that will be seasonal. It is because of this season that it is like that. Because when the surface water overruns, the sand that should be dry to absorb salt from the sea, when that sand now becomes wet, the seawater travels faster. That's why it gets to your borehole. I also want to know if it is lined. If it is lined as if there's an encasement. Yes. Yes. With a PVC. Sir. All right. So if it is lined, the intrusion is the same thing. Bí mo ṣe sọ fún yẹn lórí sà, àwọn Yerùpẹ̀ tó yẹ kán mú omi òkun dání, wọ́n ti tutù. Wọ́n ti tutù. So kò síbi tá a tó inú yẹn dé tí omi yẹn ò ní lọ sàlẹ̀, tí omi yẹn ò ní lọ sàlẹ̀ láti lọ pàdé omi tó wà nínú aquifer tí omi abẹ́ ilẹ̀ tí à ń mu. Bí mo ṣe sọ sà, tí ilẹ̀ bá ti ń gbẹ sí, omi yẹn á máa yàtọ̀ sí. Ṣùgbọ́n nǹkan tí èèyàn tún lè ṣe, ṣùgbọ́n tó ṣòro láti ṣe ní ibi tá a wà, ni pé kí bọ́ọ̀ yẹn kó lọ sísàlẹ̀ sí, kí a dẹ̀ tún kèsì ẹ̀ sí. Ṣùgbọ́n ibi yẹn táwa wà, Yorùbá táwa bí ilẹ̀ yanrìn ni. Oríṣiríṣi ilẹ̀ ló wà. Eléyìí tá à ń sọ yìí nísìnyí ní àwọn ìlú òkè kò lè ṣẹlẹ̀. Eléyìí tá à ń sọ kò lè ṣẹlẹ̀ ní àwọn ìlú òkè, torí ní àwọn ìlú òkè kí omi yẹn, ìgbà míì wọ́n máa ń fọ́ òkúta kan tó kan omi. Tán bá ti fọ́ òkúta kan tó kan omi yẹn, kò sí nǹkan tí omi iyọ̀ tó lè gbà lọ bá, torí òkúta yẹn máa dí i lọ́wọ́. Ṣùgbọ́n lọ́dọ̀ wa yìí, Yorùbá yẹn náà ṣáà ní yanrìn, omi dẹ̀ máa ń sáré nínú yanrìn. So omi iyọ̀ tinú òkun ló ń pàdé omi tó wà nínú ilẹ̀. Nǹkan tá a lè ṣe tá a bá ní àǹfààní láti ṣe ni pé ká bọ́ọ̀ yẹn kó tún lọ sálẹ̀ sí kàdẹ̀ tó wá pèsè. Tí ò bá lẹ́yìn yẹn, so lẹ́yìn yẹn a máa fara dà á fúngbà díẹ̀ tí yanrìn máa fi gbẹ. Gẹ́gẹ́ báwọn èèyàn ti sọ fún yín pé kò sí nǹkan tá a fẹ́ ṣe. A máa fara dà á fúngbà díẹ̀. Omi yẹn bóyá a fi ń ṣe oúnjẹ tẹ́lẹ̀ ni, a lè má lè fi ṣe oúnjẹ ní àsìkò yìí. Tí yanrìn yìí máa gbẹ, tí omi òkun ò ní lè wọnú, omi òkun ló ń wọnú bọ́ọ̀ yẹn. So ìgbà tí omi òkun tí yanrìn bá gbẹ, tí omi òkun ò lè wọnú mọ́, nígbà yẹn lómi yẹn máa padà sí bó ṣe wà tẹ́lẹ̀ sà. You can use yes. It will be better water. All right. Ẹ ṣé sà.
Tí mo bá kàn fi kékeré kún pé ìgbà tí mo ní Cape Town ní problem omi, èyí tó fa problem omi tiwọn náà nìyẹn, iyọ̀ ló ń wọnú omi wọn. Àwọn ìlú kan náà wà ní ilẹ̀ Arab, Dubai, wọ́n ń desalinate ni, wọ́n ń mú omi wọn, ó dẹ̀ wọ́n. Kì í ṣe táwa lè irú àwọn ọ̀rọ̀ membrane yẹn ní reverse osmosis. So wọ́n kì í ṣe nǹkan tí chemical ò lè yọ iyọ̀ because chemical ló náà. So wọ́n ní membrane tí wọ́n jẹ́ pé reverse osmosis bọ̀ tó wọ́n.
Really, èmi náà ní irú experience yẹn. I had similar experience with one borehole water not too far from my place. Iyọ̀ náà ní issue wọn. So casing tí prof sọ yẹn náà ó ní láti wà checked because kán tó mọ̀ pé casing gan ní issue yìí yẹn, back flushing ló jẹ́ kán mọ̀. So they had to rent a tank of water. Wọ́n lọ rent, they stopped pumping and then they rented tank 30,000 litre. I mean 300,000 litre, the big one, the biggest one. Wọ́n pump ẹ̀ sínú bọ́ọ̀ yẹn. Wọ́n á lọ́ọ́ ti pé báwọn ṣe ń pump ó yẹ kó kún wá sókè. Tó bá ti kún wá sókè, tí wọ́n bá ti da gbogbo yẹ̀pẹ̀ yẹn síta, then back flushing successfully done. Wọ́n ń pa pé wọ́n wọnú. Ibẹ̀ náà ti wá mọ̀ pé kéèsì yẹn gangan ló fọ́. Ibẹ̀ wá làwọn kiri yẹn ń gbà wọlé. So you might want to check maybe use back flushing to reconfirm, use huge amount of money that if you pump sí. Then àwọn ohun tí professor ẹ àwọn nǹkan tó wọ́n ní reverse osmosis àti distillation processes. Yeah. Ọmọ ayọ̀ mi, ọmọ ayọ̀ máa tún ṣe. Àwọn ẹlòmíì máa ń wò pé ọlá ń pé omi tó ba làwọn get níbẹ̀. Ọmọ afẹ́ yọ kan tún ṣe. Ẹlòmíì máa wò pé èyí tí màá fi yọ tí màá fi tún ṣe. Ẹjọ́ kí gbọ́ ọ̀rọ̀ bí. So that is it. So we'll move to the next question. Okay, I think it's okay. You have a question, okay?
Well done, the organizers. Though one of my questions has been answered by Prof, but I just want to express what the Prof said about the leaf that we are using. Then, even right now, we are using it on our side. We call it boom boom. If you put that away, if you remove all the, then the theory behind the calabash is that calabash has four sizes that can absorb. Then at the same time, calabash possesses cellular and lignin. That is why our people know that. The achievement for that calabash is actually very production. At the same time, thoughts of our willing our water to be full. That is the chemistry behind the calabash.
Thank you so much, sir, the LOC chair and members of the organizing committee, members of the community, distinguished ladies and gentlemen. My name is Adeshola Kukoyi. I work here at the University of Lagos. However, my focus has been a concept I founded, which is equilibrium perspectives and its paradox. If we see things from a perspective and its paradox, it's easier to deal with the different dimensions of the problem. And the first thing concerning water access is that, yes, in those days, people used to go to the natural surface water, and you'll be amazed that people are bathing, people are washing, people are pooing, in quotes, and it's still the same water, but there are different points in terms of the flow. And I was privileged to have gone to a secondary school in Jos that we produce our water by ourselves through windmill, but we also rely on surface water from the stream. So, but that is by the way. Now, the bottom line is that we should be mindful of the challenges of the modernization development model that we are adopting: industrialization, urbanization, and commercialization. Most of our surface waters are becoming polluted, especially in Lagos, because people channel waste, sewer in particular, directly wastewater into the water bodies. Then our industries too needs to be curbed, because some of them, their wastewater, although by law, they are supposed to treat them before they release them. But the question is, who is monitoring them? I know that SEPA is doing well, but in some cases, there are still breaches. Now, the point I want to say is that since this problem is not a static situation, it's a continuous situation. As we solve some, another will come up. So we need to have a framework that we can use to continuously address these problems, these challenges as they come up. And I want to propose that, number one, we should have a way of continuous awareness and advocacy. Especially in Lagos, you have a neighbor, you have a fence, you are solving your own problem of sewer, that is, you put a sock away close to the fence. You are not communicating with your neighbor. Your neighbor has water problem since a borehole. And before you know it, your neighbor is helping you to charge your borehole and you are pumping, sewer with the water. That I know people that have faced that problem. It's a real problem. So we need to create a lot of awareness in terms of the risk that goes with that and a culture of continuous water testing. And I think that's where the university can come up. The university can come up with a program that people can access water tests at affordable rates. That's one thing that can be done. So that's number one. Then number two is the area of reporting. When people have challenges, are there channels that they can, report for help? He just talked about his own challenge with his borehole. Is there a place or a desk or a channel that people can report the challenges they're facing with their water? Sometimes it could be industrial effluents. In fact, Yasepa is trying, like I said, sometimes some trucks will just go at the dead of night or, some areas, they will just go and put their sewer and then flush it into the water body, threatening people's health. So we should have a channel for reporting so that people can, then there should also be that for support. So that's the final thing. So let's think about that. Thank you.
Thank you. I think that is more of a comment. Yes.
One thing, you are in the space of policy, policy frameworks or whatever. There will be opportunities for collaboration, but coming up with a proposal on that can also help other people in this other community to join and to look at how to go about that. The issue of reporting, I think the university, we are already putting forward, we are recording all this. The university will communicate the university if there will be an opportunity to probably create a link or a platform that people can put in their problems and university community can look at how to build research work out of that and some other things like that. So even if it's a Google survey link or that is active, anybody can say, okay, I have this problem, who can solve it for me? Then people within the university will see a research idea from there, probably use it for funding. If the people cannot pay directly, use it to seek for fund and solve that problem for them. So it's a good idea. Thank you.
Thank you, Prof. That's actually one of the benefits of attending workshops and conferences, right? You don't just come there to listen or contribute to the theme of the project, but you can also even learn ideas that you can write on and even then push for grants that others can also collaborate. So thank you so much, Prof, for that response. So we move to the pillar lead for the Afretec pillar lead for inclusion. You're welcome, Prof.
Thank you very much, sir. Panel. Thank you, everyone. I'll be speaking from the perspective of a community health specialist, which is what I am. I'll be speaking from the perspective of the people in sociology, the social scientists, and the communicators. And the reason why I think, as well as the people in linguistics, the reason why I think it's important for this multidisciplinary approach to the issue of, translating knowledge, community-based knowledge translation, when it comes to, scientific issues like this that impacts on the health of the community and everyone as a whole. Well, the number one thing at the back of our mind is we are looking for community participation, engagement, and sustainability of whatever it is that we are looking at. The reason why I think it's important is, let's take your own program, as an example. So this is a research-based program that has influenced the life of the community, that has demonstrated, how science can be used to solve problems. And it has, as a way of co-designing, co-creation, it started with the community and they have been with you every step of the way. So fine, we have outputs, we have immediate outcomes, but now we are looking for long-term sustainability issues that can be actually tied to impact. For that purpose, grants always come and grants ends. So when the grant ends and there is no more funding, how do we ensure that all the gains, we have not lost them? One of the things that have been discovered, we're not discovered now, but we are going back to it by the social scientists, is the issue of storytelling. How do you ensure sustainable knowledge and impact translation within communities, which is also a way of ensuring that the money spent is not only spent that time, but people continue to enjoy the benefits of it in decades to come. So one of the ways to ensuring that is the issue of storytelling. What do I mean by storytelling? We all grew up, in communities where we learn most things from stories. What is the essence of stories? They tell us where we are coming from, where we are, what was done, how successful what is, what were the barriers, what were the challenges, how were they overcome. But they tell it in a way that even the layman can understand, can buy into it, and as well as remember. But the issue with storytelling is the issue of channels of communication. So fine, today we have members of the CDA who were part of the journey with us, but when you come back in 10 years' time, I mean, they might not be the same people, it might be a different set of people. How do you ensure that it's the same information, carrying the same, because all this thing is based on science, carrying the same scientific justification for that study and the scientific discoveries that brought it up, that is still valid? How do we ensure that this gets passed on? It's the same storytelling. But now, storytelling, the way it is done in the modern world, comes with the fact that, first of all, it has to be validated, then it has to be documented, and then a lot of people have to be trained on it so that that community knowledge is preserved from, I won't say generation to generation, but from people to people. And that there's always a way of validating the story. And that can only be done when we use a multidisciplinary approach, because even the science of it, we need to be sure that it's the proper words that we are using. And people who are in other disciplines whose area of focus is this thing, they know a lot more than you and I do. We can only know what we have heard. So if we do that, there is a way, and working with the local government, because that is other thing. The local government is the memory of the local government. People come, people go, but when you have documented information at the LGA level, it stays there. And people that come and they go can always look at it and learn from it, and it can be used in training. I also know that at the LGA level, the health educator or the health education unit is really involved with health-related issues within the community, and they work with them a lot. So these are units that we can work with. There's also an environmental department. So these are units that we can work with to ensure, far-reaching impact. We can only reach a few number of people, but they are in charge, they are the custodian of the whole LGA. So technically, they are involved in all these things within the LGA. They work within the world. So the reach, if we collaborate with that, is going to be a lot more than what we can just do with the grants. The sustainability of whatever it is that we have done, we also have far-reaching impact. The other thing they can help us to do is because they are the part of the arm of government. So all this reporting, all this policy we want to influence, all these collaborating with the LGA, so that when the funding stops, we can find a way of bringing them in to continue the journey from where we have stopped. And I think it's really very important. And I'm sure that all the reps here, they work with the LG, they work with representatives at the LGA level. So I'm just thinking that is a way that we can look at it. The other thing is, for us as researchers, again, is that we also publish storytellings. They are publishable right now, and they can be used for grading, whether you want promotion or whatever, in high impact journals. So that is a win-win for everybody. Thank you very much.
Thank you so much, Professor Shekoni, the Kenya Lead for Afretec Inclusion Technical Working. I don't know if our professors have maybe any closing remark before we close this session. All right, okay.
I want to appreciate every one of us, and my closing remark is, please, let's continue to work together. The relationship is mutually beneficial. even when we are not reaching out to you, please reach out to us. I'm not saying you are not busy, but we are also very super busy. So I don't know who is busier between the two of us, but it's a relationship that we should keep open. We must tell you that it is mutually beneficial. So please, if communication is easy now, if you just say, we have a WhatsApp group, but it's not that so active, if I'm not mistaken. Or is it only with Wire? I know we have a WhatsApp group with also Ilaje. I think we have. But probably I would look at it just to say, oh, hello. I should say hello to you. So let's keep the channel and the communication open so that we can be able to sustain storytelling that we have had. Because if a grant ends, it doesn't mean that we just say, oh, we are not interacting with this community again. We have learned from each other. Let's look at how to maintain the relationship.
Thank you so much, Professor Ngadi. And Professor Fikuni, thank you for that framework. I think it's that framework, if you follow it squarely, is going to sustain the relationship between the gown and garment. That's what they say. I was going to say that if the mountain does not go to Muhammad should please find a way to get, and that's exactly what Professor Agumbiade said. Like Professor Amuda said, we will not just leave these communities without leaving a footprint of this research. And that, I think, will continue to bring us together, because whatever eventually is done, it's not just going to be a one-time thing. We're going to set up sensors. We're going to keep gathering data so that when Big Daddy's well is getting intruded, our own well also will be intruded, so we can come together and provide solutions. We have started this journey, and I think between University of Lagos, the Afretec Water Sustainability Group, I think it's a lifetime journey that will last beyond even our time. Thank you for all that you have done for us. We really appreciate you. Thank you, Paul.
Okay, so I'll just go with what has been said so far. Okay, if I should add something, when we're talking of communicating the information, I wanted to say that I also saw so I went for training somewhere, and I saw where they communicated outputs of research in languages, actually. So they had it in the languages of all the communities that they had practiced it in. So we even saw Hausa there, and it was computed in Hausa, and also it was like a clear breakdown of how the research could be used by the communities. So I think it's something that can be looked into. I don't know if it's under this grant, because this grant is already been rounded up, but subsequently.
All right, thank you so much for the patience so far. I'm just going to say that it's not going to be about, it's not just going to be talking. Yes, we are in the lab, we are working, So like Prof said yesterday, Professor Amda, that they are going to sink boreholes, at some places. And even aside that, we are still in the lab working on household skill, solutions, not just community skills, something, we can bring to you and you can use in your homes, to purify water. So it's not just about talk. We are actively in the lab working on solutions. Thank you very much.
Okay. Thank you very much. I'm also a member of the team, and my own closing remark is so our distinguished panelists, I say thank you so much, and to our participants as well. Thank you so much for coming. I think we can now bring this session to a close. Thank you, Prof. Thank you, wonderful colleagues. Thank you, participants. So, announcement, please.
All right. Okay. Thank you so much. It's been a wonderful journey, and I think we're not closing it here. After this time out, we'll still come back to have our community speak to us what we have done so far. But right now, we're going for a break. Tea break is available, and I think we need to have it now. Thank you so much. God bless you.
Vibe life, vibe life, vibe life.
coming to the end of the conference. In the next 30 minutes, we want to wrap up everything. In the next 30 minutes, we want to wrap up everything. We're targeting 1 according to a program. And the last video. And we'll do the development. Targets rule for you will from that so we actually this one first also
engage and inform on how to stop what one people are also and from now we are going to and yesterday I think this basically person I think all is to do considers advocacy therefore therapy address how to suffer food and water. So these like proper also also Water. Continue to pray and continue to make you see. I know it's not the person that will be part of this, the care community, but all community was. And so I people all authority program. We are now chairman and how we are doing not going to be like those who and going forward, before
Within the community. And actually,
Hello.
It's never. The professor that is declared the government first. This month, workers,
If you want to interact, but the conference is over. Thank you very much.
Yes.